So first off, we're going to differentiate our shine x. So inverse shine x, same thing. And it's the same method as we did in the A2 differentiation pack. So rewrite this as x equals shine y, because we know how to differentiate shine. We can then differentiate this, but it'll be dx by dy on the left-hand side. Differentiating shine x, shine y, we know goes to cosh y. Don't need to worry about any minus signs with these. And to get an expression for dy by dx, I'm going to use the fact that dy by dx is 1 over dx by dy. So if I just flip this, I get dy by dx is 1 over cosh y. Now I want to turn this back into shine y so I can replace it in terms of x. So I'm going to use the identity that we've got for this one. So remember the identity again, this one's on the formula sheet. So you can use cosh squared y minus shine squared y is equal to 1. Or if we rearrange this to make cosh y the subject, cosh y is 1 plus shine squared y, all square rooted. And then we can replace this in our dy by dx. Dy by dx equals 1 over cosh y, but instead of cosh y, I'm swapping that for root 1 plus shine squared y. Finally, going back to the start, shine y is just equal to x. So I can swap shine y in here for x. So 1 over root 1 plus x squared. Okay. Like that. You can also do the same for cosh. You can do the same for than as well, or r cosh and r than. To get those results, they may ask you to do that, but it's all the same sort of thing. Okay. So we've been given that y equals r cosh x all squared. It wants us to prove that this thing here is true. Okay. So let's just start off trying to differentiate this and see what happens. So I'm going to need to use the chain rule to differentiate the right-hand side. So differentiating the right-hand side using the chain rule, I differentiate the inside. So differentiating r cosh x, I can just use this here. Just quote this result. So that's 1 over root x squared minus 1. Let's differentiate the inside, and then differentiate the outside function. That's just a bracket squared, so I'm just timesing by the power and minus 1 from the power. Power 1, I just leave it off. And the thing inside the bracket stays the same, so it's 2 r cosh x. Okay. Look at what we're trying to prove up here. So there's a x squared minus 1 on the left-hand side. So I'm going to times up by this root x squared minus 1 dy by dx equals 2 r cosh x. Don't need the bracket anymore, it's just got 1. Looking at this, I'm thinking, well, I'm probably going to square this because that'll end up with the correct thing on the left hand side. So if I square both sides, I get x squared minus 1 dy by dx all squared. On the right hand side, 2 squared is 4, and I get r cosh x squared as well. All you've got to do now is notice that r cosh x squared is just equal to y from the original question. So again, this equals 4y, like that. Okay, so it's one of those where it's not obvious how to get to the answer that they've asked for, but I mean, you look at this and think it's got a dy by dx. Let's try differentiating it and see what drops out from there. It just Example 3. So differentiate r cosh shine 2x again. It's a chain rule question because it's a function inside a function. So if we differentiate the inside of this, differentiate in shine 2x, shine differentiates to cosh. Because there's a 2 in front of the x, because the chain rule needs to times by that as well. So shine 2x differentiates to 2 cosh 2x. So that's differentiating the inside function. Then I've got to differentiate the outside function. So using the result for r cosh again from the formula sheet, that's 1 over root. Usually it's x squared minus 1, but instead of x here, I've got sine 2x. So I replace x with sine 2x. So sine squared 2x minus 1. You're looking at this and thinking maybe you can use an identity, but I don't think you can. Remember, the identity is cosh squared minus sine squared equals 1. So 1 plus sine squared equals cosh squared. If it had been that, that'd be nice, but it's not. It's just that. So I'm just going to leave it like that. You can write it all together. So 2 cosh 2x over root sine squared 2x minus 1. To be honest, a question where it just says differentiate, as long as you have a correct form, it doesn't have to be fully simplified. And obviously you can get asked to do any tangents, turning points, all that kind of stuff, normals, whatever, for this kind of stuff, so it's all the same. So finding the equation of the tangent to this curve, so r sine 3x squared, doesn't need to be brackets on there, but it's worth putting on just to demonstrate that that 3x squared is inside that r sine. For x equals 2/3, and it wants it in this spot. First thing I'm going to do is get dy by dx so I can work out the gradient. So I'm differentiating r sine 3x squared. So another chain rule question. So differentiate the function on the inside first, which gives you 6x. Differentiate the outside, so this time we want the result for r sine, which is this one. So 1 over root 1 plus x squared. So times 1 over root 1 plus x squared, but instead of x this time we've got 3x squared. So that's 3x squared. Okay. I will put this together. So I've got 6x over root 1 plus 9x to the 4 in here. But then all I'm going to do to work out the gradient is substitute in x is 2/3. So m equals 6 times 2/3 over root 1 plus 4. Stick all that in your calculator. Okay. 6. Let's do 3. Root 1 plus 9. That's nice, gives me 12 over 5. The gradient. I also need a y value to work out the equation of the tangent, because I've got the x value, so I need y. So I've got r sine. So you can just put this one. So work out this here. 4 over 3. So this is r sine 4/3. And if you stick 4/3 into your ln formula, so ln 4/3 plus root 4/3 squared plus 1. You can work out the bit inside the ln in your calculator if you like. 4 over 3 plus root squared plus 1 gives us ln. We've now got enough stuff to work out the equation of the tangent. So using y minus y1 equals m x minus x1. This is the equation of the tangent. It needs to be in the form ax plus by plus c equals 0. So let's expand this out first. So 12 over 5x minus 20. 8 over 5. 12 over 5 times 2/3. Times 2 by the 5. 5y minus 5 times 3 is 12x minus 8. And then collect everything up on one side. I'm going to take everything to the right hand side, so I've got positive x. It doesn't actually. So 12x minus 5y minus 8